Okay, so the question has risen about what to do if the bases cannot be made equal. So we have an exponential equation and the bases cannot be made equal. This is the method we're going to use. What's the inverse of an exponential? What's the inverse of an exponential? A logarithm, right? So if you can't solve it by dropping the bases, then what you can do is you can solve it using logarithms. Right, Nighthawk? So if the bases can't be rewritten so that they're both the same, solve the exponential equation using logarithms. You can use the common or the natural log. It doesn't matter which, but it is important that you use one that your calculator can handle. You wouldn't want to use a log base 7. So you're either going to use log base E, just the LOG log, or natural log. And here's kind of how you're going to do it. You must isolate the exponential first. So get the piece with the variable on one side by itself. If there's more than one, isolate one of them. Then apply the log or the natural log to both sides. Now note right here that if your base is E, use natural logs. That just should make sense. And if your base is 10, which one should you use? LOG log. Other than that, it doesn't matter which. So some of you could have a natural log answer and some of you could have a common log answer, but they would end up being equivalent if you turned them into a decimal. So apply the log or the natural log to both sides, then use the power property to bring the exponent down to the front. That's going to allow you access to the exponent. Then do whatever you have to do to solve for the variable once you've brought it out of the exponent. So those are the steps we'll take. Let's start with a really easy one, just something kind of quick. Let's start with 5 to the x equals 3 to the 1. 5 to the x equals 3 to the 1. What's the base of the exponential? 5. Is there any way to turn 5 and 3 into the same power? No. I mean, first off, they're already prime. They can't be rewritten as anything smaller. So we can't do anything with them. So we're going to have to solve them using logarithms. So first we need to isolate the exponential. So 5 to the x is already by itself, right? Okay, then you have to decide, would you like to use common log or natural log? Common log? Okay, so apply the log to both sides. So put an LOG in front of this one and an LOG in front of this one. Remember that you can do this as long as you do the same thing to both sides. That will allow you to use the power property to the left side and let you bring that x out into the front. So the x will come down and become the coefficient. So now we have x log of 5 equals the log of 3. You all okay with that? Yeah? Okay. Now that the x has dropped out of the exponent and is down in front, I can get rid of this log of 5 by doing what? What's it doing to the x? It's multiplying. How do you undo multiplication? Division. So we're going to divide both sides by the log of 5. And that's your answer. X equals the log of 3 divided by the log of 5. Now, if I ask for the exact answer, you are done. That is called the exact answer. There is no error in that. But if I want you to approximate, I will tell you how many decimal places to round to. Type that into your calculator and give that to me to 4 decimal places. The log of 3 divided by the log of 5. What did we get, guys?
0.68.
So 0.6826? Okay. That's your approximate answer. So you need to pay really close attention on CalcChat to see what they're asking you for. If they want you to stop and leave it in log form, the exact answer, or if they want you to give it an approximate form and round it as a decimal. One last thing. Someone type in their calculator the natural log of 3 divided by the natural log of 5 and tell me if you get the same thing. Natural log of 3 So see, it wouldn't matter if you had used natural log or common log. So this is also another answer in exact form. It could be either one of those. Does not matter. So because there are 3 different ways you could write that answer, you need to pay close attention not to CalcChat but to WebAssign. Sorry about that. To WebAssign and see which one they're asking you for. So read carefully before you work your homework problems. The final thing you should do is you should store your answer for x and check it back into the original. So 5 to the x power, does it equal 3 when you store it? Excellent. Let's try another. Let's take a look at 6 to the x minus 3 equals 2 to the x. Now this problem's a little more complicated because both sides have variables in the exponents. Can we turn 6 and 2 into the same base? No. But 6 is 2 times 3. But that's not the same as having a base, right? Just because they have a common factor doesn't mean they have a common base. It would have to be 2 to the 3 or 2 to the 2 or something like that. And 6 won't work. 8 would and 4 would, but not 6. So we're going to have to resort to logarithms. So do you guys want to use common or natural? Natural. You're going to do natural on this one since we did common last time? Okay. Let's do the natural log. So because they're exponentials on both sides, it doesn't matter which one's isolated. It turns out they're both isolated already anyway. So we'll take the natural log of both sides. And then we will apply the power property. That will allow us to bring the x minus 3 to the front. Be sure you put it in parentheses so that we have x minus 3 times the natural log of 6 equals x times the natural log of 2. That's where this problem gets a little more complicated than before. Anybody have any ideas about where to go from here? Does anybody have any idea what I'm trying to do?
Get x by itself.
Okay, we're trying to get x by itself, which means somehow I've got to get all of my variables together on one side, right? So the first thing I'm going to have to do is, well, if I divide by the natural log of 6, what does that do?
Yeah, the x will be stuck.
But I still have an x on the other side, right?
Yeah.
So here's the trick. When you have a binomial like that, you have to distribute. And instead of dividing right away, because otherwise you'll just keep mixing up your variables and your natural logs. If you distribute, it will turn it into a sequence of addition and subtraction, and it will allow you to move all of the ones containing an x to the left and the terms that don't have an x to the right. So let's go ahead and distribute, and we have x natural log of 6 minus 3 natural log of 6 equals x natural log of 2. So now we can see it as 3 distinct terms, and 2 of those terms contain x, and 1 of them doesn't. So I'm going to rearrange it. I'm going to put all my x's on the left. So I'm going to keep the x natural log of 6. I'm going to subtract the x natural log of 2. And then what about that negative 3 natural log of 6? Which side does it need to go to?
Add it to the right.
Yeah, it needs to go to the opposite. So we'll add it over, and it will become positive 3 natural log of 6. So we just took that step and we rearranged it so that all of our variables were on the left and all of our constants were on the right. Because these two on the left are not like terms, how do I separate that x from them? It's a little trick we have to use sometimes with literal equations. How do you get that x away?
It's
Pull out a grace compact.
pull out an X, yeah.
Yeah, pull out an x. So we factor the x to the front, and that leaves us with the natural log of 6 minus the natural log of 2 is equal to 3 natural log of 6. And then for your final step, you can just divide by that parenthesis, and the x will be by itself. So it's weird. You get rid of the parenthesis, then you bring the parenthesis back once you know that you can factor in x out of them. X equals 3 natural log of 6 divided by the natural log of 6 minus the natural log of 2. That is one possibility for the exact answer. You could also have that exact same answer with LOGs instead of natural logs, with common logs. Now I'm about to show you something. I don't know if you're going to really see it right away, but take a look at this. Is this also the same answer? What did I do?
Yeah, you
Just
divide.
cancel it out.
I used the division property, right? And said 2 logs subtracted is 1 log divided. Is this the exact same answer? What's 6 to the 3rd power?
216. Because you just
Yeah. So any one of those, I use the exponential property there, right? I brought this 3 back here. Any one of those could be the exact answer. I'm fine if you stop at the first one. And it shouldn't matter on WebAssign either. But I also would like for you to give me an approximate answer to 4 decimal places. So if you could type any one of those into your calculator, please. And give me the approximate for those. We'll pause for a minute, let you get the decimal approximation and let you check it. Store it for X and check it. So when we type in the exact answers, we get an approximate answer of 4.8928. And if we store our answer and check it back into the original, the 2 sides are exactly equal to each other. So that's how we know we got it correct. These are the final 2 examples for exponential form. So even though this video is going a little long, let's go ahead and knock these out. And then we'll stop when we start logarithmic equations and we'll start a new one. Let's take a look at part A here. I have e to the x plus 5 is equal to 7. Now because this is base e, I want to make sure I use which logarithm?
LN.
The natural logarithm. It's not actually, you wouldn't be wrong if you use the common log, it would just be a little longer. The natural log actually makes your work a little less, which is nice. So, let's go ahead and let's apply the natural log to both sides here. If the natural log of e to the x plus 5 is equal to the natural log of 7. Because the exponential was already isolated, the first step I had to do was go ahead and take the natural log of both sides. That allows me to bring the x plus 5 to the front. So it drops down and becomes x plus 5 times the natural log of e is equal to the natural log of 7. Well, at this point, normally, I would distribute that parenthesis, right? But what is the natural log of e? Ask your calculator. What is the natural log of e? You should know this right off the top of your head. 1. Why? Because what's the base? E. And e to the 1 power equals e. So the natural log of e is 1. And anytime you're in base e and you have the natural log of e, that whole thing right here just becomes 1. So really that's x plus 5 times 1, which is just x plus 5 equals the natural log of 7. So it's really easy now. What's the last step?
Subtract 5.
Subtract 5 from both sides. So we have x equals the natural log of 7 minus 5. That is the exact answer. Now that does not become the natural log of 2. Those are not like terms. One has a natural log and the other does not. Y'all okay with that? All right. Now, type that into your calculator and give it to me to 4 decimal places. Natural log of 7, close your parentheses, minus 5. Natural log of 7 minus 5. What'd you guys get?
-3.054.
5, 4, 1. Let's go to 4 decimal places. Are we allowed to have a negative answer?
No. Not, with
Not
the
after a
log.
log. But can you have a negative answer to a log problem?
Yes.
If you're not sure, check it. Store it and check. Always store and check. We store that for x and we check it. e to the x plus 5, do you get 7? So it turns out you're allowed to have a negative answer. Be really careful with that then. Make sure you check this. For our final problem, look at 4 to the x plus 3 equals 8 to the 2x. And notice that was the very first problem I think we did together. Because that problem, both of the bases could be rewritten as powers of 2. So if you look back at that very first example from today, we got an answer of, was it 3/2? Yeah? So can I work this using logarithms? I should be able to. That should work for every problem. It may not be the easiest. It's probably easier if we work it using like bases. But if you forget to do that, you can work it using logarithms. So I want to show you how to do that as well. LOG or natural log? Common log? You guys want to do a common log? Okay. Take the common log of both sides. So we have the common log of 4 to the x plus 3 is equal to the common log of 8 to the 2x. Use the power property to bring your exponents down in front. So we have x plus 3 times the common log of 4 is equal to 2x times the common log of 8. Because I have variables on both sides, I need to distribute this binomial. I have x log 4 plus 3 log 4 is equal to 2x times the log of 8. So we distributed. Now we need to get our variables on the left and our constants on the right. So we'll keep the x log 4. We'll move the 2x log 8 over and make it negative. And we'll move the 3 log 4 to the other side and make it negative. Then how do I separate the variable there? I factor the x to the front, yeah, so bring the x out, and that leaves you with 1 log 4 minus 2 log 8 is equal to negative 3 log 4. And then divide by that parenthesis, and you get x equals negative 3 log of 4 over the log of 4 minus 2 times the log of 8. Does that make sense, guys? I know that went a little fast. But you can always go back and rewatch it later. Does everybody kind of know what I did? Type that into your calculator using alpha y equals. Make sure you close the parentheses where you need to. And tell me what that is.
Could you move that 3 if you wanted to keep going?
Sure.
And it's 2?
Yeah, you can move the negative 3, you can move the 2, and then you could use all kinds of properties, and you probably would see it.
Yeah.
But you are holding a calculator, so you should be able to type it in. What'd you get?
1.5.
1.5. So it wasn't even a big decimal. It was 1.5, which is the same as 3/2. So if we applied the properties of logarithms to this, we moved the negative 3 to the back, we moved the 2 to the back, and then we combined it using division, then you would understand why it equaled 1.5. Make sense? Great. Okay, that's all for exponential equations. So it shows that you can sometimes work them 2 different ways. Let's start over and work on logarithmic equations.